right, we are recording. This is Introductory Statistics, November the 4th. And the next thing is our schedule. Here's the schedule, and if we look at November 4th, you see that we're doing confidence intervals. We have homework set number 10, which is due. And then next week, we'll have plenty of work to do for homework set number 11, hypothesis testing. So, the next thing then would be any questions that you might have. So does anybody have any question about it?
I have a question on the point estimate.
I'm sorry, Mary, I didn't have my headphones.
Sure.
So
On question 4, I can't figure out what the point estimate is. I got the other part right, but.
Right. So when we say point estimate, what we're actually dealing with there is the idea that when we do any kind of a survey or anything, we're going to get one single number, and that number is from a sample, but it is an estimate of what the population number would be.
Is that the same as the p-hat?
It is.
Okay. And I'm still, I'm not sure why I can't figure that one out.
Okay. So from last time, when we said, what is p-hat? We had a formula for that. So Mary, do you have reference to what we did last time?
I do. If I can find it in my paperwork. I know it's something divided by, it's n divided by x, I believe.
Nope, it's x divided by n.
X divided by n. X divided by n. Okay.
So do you know what those numbers mean, though, Mary?
Okay, well, n is like this population.
No. N is not a population. Can somebody else tell me what n stands for?
What is it?
N, as Melinda has said in the chat, is sample size.
Sample size. Population.
Okay. So Mary, when you look at this problem and you ask the question, what is the sample size? What would you say?
Sample size is 224.
Okay. And then do you know what the number, what the symbol X stands for, Mary?
I believe that's the 70 people, but I'm not sure if I'm supposed to put it as 70%.
Does it say percent?
No, it just says 70 people.
So then it's not.
Okay, so it's just 70 divided by 224.
Okay.
Okay.
Now, everybody else is going to have different numbers compared to what you have.
Yeah, because I came up with 0.3125, but I guess the correct answer is 3.2.
No, the wrong answer is 3.2.
The wrong answer is 3.2. Okay.
I'm looking at what you put on your homework, and it's 3.2, and it's marked wrong.
Okay, I didn't know if they like put in there. Okay, so let me see. 3120. Oh, shoot. What's going on? Yeah, because it won't let me now. I guess I did all my chances.
All right, well, I can fix that for you, Mary.
Okay.
So grant extension submission. All right. Now, the reason why I have a limited number of submissions, Mary, is just for this reason, okay? So that when you have trouble and you can't get something, you'll ask the question about how to get the answer instead of just trying all the different numbers in all possible combinations, because I want you to understand what it's talking about. What we're doing is a point estimate of the proportion or the percent or however you want to describe it, okay? So then when we take x divided by n, we get that number. So I think you should be able to try again now. And it should work for you. All right. Any other question about anything on the homework?
Did you say we can ask a question about the homework?
Yes, I did.
Okay, I have a question on number 8. Number
right.
8, part C.
Okay, you're a little bit laggy there, Darcy, but I think you said number 8, part C.
Yes, correct.
Okay. So what we have is a list of 5 different numbers. And you're supposed to get the standard deviation of that set of 5 numbers. That's for number 8, part C.
Right. I don't know what formula or how to get that standard deviation, I guess.
Okay. If you look back at, I think it was week 2, that we had a description of how to get the standard deviation, and we had a formula for how to do it. But I don't want you to use the formula for this. I want you to use technology to find the standard deviation of these numbers.
Okay, I watched all your videos and I guess couldn't figure out how to do this in SALT. Or what kind of technology are you referring to?
Okay, I'm referring to SALT. And this would be a situation where you have these 5 numbers. You need to put them into SALT. And so I'm hoping, Darcy, that you remember how to get a set of numbers. You don't have a button here to get it into SALT. So
Yeah,
you're going to have to put it into SALT by putting it into a spreadsheet and uploading it into SALT.
But because it didn't say use SALT, that's why I didn't know we could use SALT, because it didn't have a button. Usually if you use SALT on a problem, it will say on the problem. So that's why I was confused, I think.
Okay, so yeah. What I'm going to say to you is that you can use SALT for anything that you need to use SALT for, okay? Anytime we need to calculate something, you can use SALT, and it's okay to use SALT to do that now, okay? The other part to that is it's fine for you to ask the question, okay? It doesn't bother me that you ask. So from here on out, you can always use SALT to figure stuff out. Now, again, just to think about what we've done in the past. That's a little bit why this question is designed the way that it is, okay? So that when we say, how do you find the standard deviation, that you would be able to go into your notes that you did in the past, and you would say, how did I find the standard deviation in the past? And I know you've watched videos, that's not a problem, but that you would have in your notes a place that you would say, to find the standard deviation, this is what you do.
Okay, I think I can handle that. The only thing
Okay.
is I went to the math help center, and they really confused me and gave me this big formula and wanted me to do it by hand, and I couldn't understand it. And that's, I think, where I got confused, I guess, because the math formula with, I didn't even know how to do the formula. So that's where I guess I was confused.
Okay, I understand.
So does the math center not utilize SALT then?
This is a complicated question, Darcy. I'll try to answer
Okay.
the best I
I
can.
just get confused when I go
Okay.
to like the math center or somebody else and ask for help, and then they're at a different level talking about different things than what I'm used to, like in your class. So
Yes.
that's kind of hard.
It is. It is. And so that's another part of navigating this experience, which is learned by experience. So this is another great question, Darcy, and I really appreciate it. The fact is, okay, in any math class, in really in any class that you take, right? If you get help from somebody outside of the class, it's possible that they don't have the same way of doing things as what we did in the class, right? And so then if they say to you, okay, you need to do it this way, but it's not the same as the way we have done it in the class, then it's kind of like a thing where you don't always necessarily say, oh, I'm going to take everything from how this person said to do it. Now, the in the math center, okay, Julia, who's been around for a long time, she knows a lot about the course because she's worked with me for years. And so she knows, hopefully, that that's what you need to do. Other people who are in the math center, they may not know that, okay? They may not know that I emphasize using the technology to do a thing. And so they will go and they'll take you back to the formula and try to help you to use the formula. And I'm going to mention this, Darcy, but it's not a fault of yours. The fact of the matter is we did do this with the formula in the past. I believe it was on test 2 or 3 that I had a list of numbers and I said, you have to use the formula to find the standard deviation. And so that is something that we did, but now that we've done that, we don't have to do it again. We can just use the technology. And so anytime you take a class and you go to the math center or anywhere else for help, and you say, I want help on this particular problem, they may not do it exactly the way that I do it, and it may not actually match up. And I understand that that's confusing and difficult for you when you go somewhere for help, but it's not the same help that you need, okay? And so I really appreciate you telling me about that, because now I can communicate to the math center and I can say to them, we use technology. People don't have to use the formulas when they're doing these kinds of calculations. So then we can clear that up. But you're right, it does happen and it is confusing. And so hopefully now that you've asked this question, I'll communicate with them and make sure that they know that that's not necessary to do. All right?
It wasn't Julia. She's on vacation or not here this week.
Yeah.
So
I didn't think it was.
Yeah, it was like another lady. And so I was doing my homework, and it's kind of like when I'm doing homework, I like to complete, the question. So that's when I went to the math center when I was having problems and I didn't get anywhere with her. So I just wanted to,
Right.
let you know that,
Yep.
I guess.
I
But yeah, I
appreciate
do know
that.
how to do in the past, how to do that. I think I was just studying too much that day and had too much going on and
Yep.
overwhelmed.
Sure.
Well, thank you.
Absolutely. Okay. And I really appreciate what you just said too, Darcy, because it is true that anybody, I don't care who you are, when you get to a certain place, it's not productive for you to continue, right? And so then to know how that feels and to be able to kind of know when to step away, that's really good for you to recognize that. So good. Very good. Thank you. All right. So again, as we just said, for this problem, you will need to find the standard deviation of these numbers using technology. You can use a spreadsheet and put them into SALT the same way as you would for a project or for anything else. Or you can use Excel or Google Sheets if you want. Those are other ways to find the standard deviation. If you're used to that, you can do that, and it will give you the information just as well. Okie doke. Other questions about the homework then? All right. So what we're dealing with now, well, just as a review, okay, and I'll go to the agenda and I'll put this in there. Our general topic is the idea of the confidence interval. So can someone tell me what is the purpose of the confidence interval? What is our goal when we use confidence intervals? What are they for? What are they about? Why are we using confidence intervals? What's our purpose?
To get a population measurement?
Yes, Jamie, that's correct, to get a population measurement. Now, Melinda, when you say accuracy, no, not really. Our general goal is to get an interval that predicts a population measurement. Okay, that's what we want. And I had this in the agenda last time, and I'll just paste it right in here. Confidence intervals are used to locate a measure of the population. That's what they are for. Okay. And the first one that we had was the confidence interval for the proportion. And what we're talking about here is P is the population proportion, and that's what we worked on. Okay. And now we're going to expand this, and we want the confidence interval for the mean. So can someone tell me what is the symbol for the population mean? Jamie, you were quick on the trigger for that previous one. Can you tell me what the symbol is for the population mean?
I'm looking through my notes right now, and
Okay.
I'm not exactly seeing that.
All right. So I'm
You're
gonna
looking
put it.
for the symbol. We repeat the question again. I'm sorry.
Yes, certainly. I'm looking for the symbol for the population mean.
Symbol for the population. Yeah, I got nothing right here that I feel like I wrote it down, but
Okay.
I'm not seeing it. I'm sorry.
That's okay. I put it in the agenda. It's this Greek letter mu. Greek letter mu is the symbol for the population mean. And we are using the sample mean. So I wonder if I have any better luck with this. Can anybody tell me the symbol for the sample mean?
I don't know the name of it, but that little round circle.
No, sorry,
No.
Mary, that's not
Okay.
correct. X with a bar over it, also known as X bar. Yes, Melinda, that's correct. So we're going to use the sample mean X bar, and from the sample mean, we want to figure out an interval that will tell us where the population mean is. Population mean is mu, sample mean is X bar. All right, so that's what we're about. That's what we want to happen. So if that's what we're about and that's what we want to happen, okay, so then I want to get that. Let's do an example here. Talk about how this works. So put this in the agenda. I'm going to do a survey of 15 children in 5th grade. And I get that their average height is 55.3, and I know the sample standard deviation is 4.6. And what I want to do here then is to find the 95% confidence interval for the mean. All right. So I want to go through the steps of using SALT in order to find this answer. All right. So can anybody tell me where in SALT should I go? Yes, Melinda, I go to inferential statistics. So that's where I'm going to go. And Melinda, can you tell me what procedure selection I want to use here? I need one sample T, that's correct. And we'll talk just in a minute about why we use one sample T, but this is what we want. And I'm gonna share my screen here so we can see how this looks. right. So I'm in salt. Doing 1 sample T. And I'm going to put in my numbers. So, Jacob, can you tell me what numbers I'm going to put in these blanks based on what I have in the agenda? Okay, Jacob, you're not coming through. I can't hear what you're saying. So maybe your microphone's not cooperating today. Okay. So Jacob's going to type his responses here. Sample size is 15. All right. Standard deviation is 4.6. And the sample mean is 55.3. That's correct. Okay. So then, hopefully it's clear. The next thing we're going to do is we're going to click on the confidence interval for mu. And that's why I wanted to talk about it before we did it. Okay. The symbol for the population mean is mu, and that's what we're going to be finding, the confidence interval for mu. So we click on that, and then we have to determine how confident we want to be for our results. It's set at 95% already, so then we hit this number and we generate results. And we have a 1 sample T confidence interval summary, mu, the mean of the population, the 95% confidence interval for mu. So I want to know what our answer is for the confidence interval. Mary, can you tell me what the answer is for this confidence interval from what I have in SALT?
We are 95% confident that the levels fall between 52.75 2605 and the upper limit 57.84 7335.
95. But yes, okay.
Okay.
And I'm sorry, you said, you kind of broke up there. You said what is it that falls between those two numbers?
Our confidence level of 95%?
No.
No.
No. What thing?
Interval.
What thing is between those two numbers? Okay, we'll go with 52.8 and 57.8.
The mu?
The mu. That's correct.
Okay.
Or the population mean. That's what's between those two numbers.
Population mean.
So what happened? I have 15 students in the 5th grade, and I find their average height, and I consider them to be somehow randomly selected. I'm not just using a convenient sample, I hope, not just picking 15. But anyway, regardless, I have 15 children. I find their average height. of 55.3 inches, I know that is not the average for the population at large. And so I asked the question, what is the average height of fifth graders in general? Not just for this small group, but in general. And based on the mathematical formula here that SALT is using, I am 95% confident that the population mean of all fifth graders that correspond to the group that I'm doing here would be basically 53 to 58 inches. Now, if I'm choosing these 15 students at random from students in lacrosse, then I would say this would apply to fifth graders in lacrosse. If I'm picking these 15 students at random from the United States of America, then it's possible that I would say this is true for the United States of America, that this is what the mean would be. So the population that I'm talking about here depends on how I got my numbers. Was I picking randomly from people in lacrosse, people in Wisconsin, or people in the United States? It depends on how big my group is in terms of my population. But this is what I've calculated right now. All right, so does anybody have any question about the process of using SALT to make this happen? Okay, so now that we've done that, now we need to talk about how this works, right? The first thing that I want you to know is that we have what are called T-scores with this. And a T-score is something where we're using a different kind of a process than we had with Z-scores. They're not the same. Okay? And so what we have here then, we have to use something that's not the same as Z, it's T, and that's why they said one sample T when we used SALT here. One sample T confidence interval. And that's the procedure selection one sample T. So what we're saying is, similar to Z-scores, all right, there's a mathematical curve that we think this is going to look like. But it's not the same as Z, it's now T-scores. Why do we have to do that? It's because when we're doing this and we want to say, well, how much of a variation are in these numbers? Well, the standard deviation that we're getting here, we don't actually know if this is the correct standard deviation. So we don't know the mean, and we also don't know the standard deviation. And so because of that, the mathematics changes, so we have to use these things called T-scores. So when we have these two types of variation, it means that it's going to be different. The tails are going to look different. So what we're going to do is we're going to go out here to SALT again, and we're going to look at our distribution calculator. Here we had the normal distribution with Z-scores, which was fine. But if we pick the T distribution, okay, it's going to look a little bit different, and it's going to be based on this thing called degrees of freedom. If we have high degrees of freedom, it's narrow, but if our degrees of freedom get low, then it's not gonna look like the bell-shaped curve. It's gonna have a different formula for the tails. So this T distribution is going to look different. The tails are going to be different from our z-score. Now, we use SALT already, and we already got our answer, okay? But I want you to understand that you need to be using t when we talk about the mean versus z when we are dealing with proportions. So, how or what is involved here? So the shape of the graph changes with different sample sizes. The degrees of freedom are related to the sample size, and the degrees of freedom are n minus 1. So when we were looking at this previous example and we said it had 15 children, then that would mean our degrees of freedom is 14. And if degrees of freedom are 14, then, you know, if you see here we have like these different shaded areas, you can see how we can adjust that if we want to. But just so that you believe me here, I hope, when we deal with something with a mean versus proportion, we use this kind of mathematics, then the t-score is what we're talking about. Now, as you may recall, all right, last time we worked on this, we said there was something called a z critical value. Well, the same thing is true here. We have a t critical value, all right? And when we have a t critical value, then the critical value is telling me, how do I find the tails? How do I get my two tails? And so I'm going to have, just like we did before when we did critical values, we used between and we put in the probability to find the z critical value. The same thing is true here. I have 14 degrees of freedom. I click between because that's what I want for my critical value. So I go over here and I click between, and then I'm going to put my 0.95 in right here. And now I have my critical values. So I want to see if we can get back to what we did last time. Can someone tell me what is the z critical value for a 95% interval? If I'm using z, then what is the number I have for a z critical value for 95%?
Is that the 1.96?
It is. Congratulations, Mary. You win.
Thank you.
It was 1.96. But with the t distribution, we put it in here. It's not 1.96. It's 2.1448. So with the t distribution, it's changing the shape of this curve. And so in order for us to have 95% confidence, we need to go out a little bit farther, right? 1.96 versus 2.14. That's not a whole lot different, but it's something. Okay. So mathematically, we're using this t distribution in order to get the answer that we want about confidence intervals. And again, what I just did, SALT does automatically when we go ahead and put in our information in that inferential statistics. We put it in the inferential statistics, it goes through the whole process, it figures out the t-score, it works with the standard deviation, it works with the sample size, it makes everything work. So that's one thing, okay? But this is when we say, what is the t critical value for a certain size of a sample. And we'll be working with this kind of stuff down the road. So we want to kind of know how this works. So now you hopefully know how to use this distribution calculator for the T distribution. It's a little bit different than what we had with the Z distribution. All right, so there's something. All right, any question about this so far? All right, so what I want to do next is see if we can make this work. I'm going to put a question in here. In the agenda, I want us to see if we can figure out an example here. Find the critical value of T if we're working with a sample of 20 veterans. We're measuring something about veteran services. And we want a 90% confidence interval for the mean. I want to use SALT to find the critical value of T in this situation. All right, so I will give you a minute or so and see if you can make this happen. Now, Aaliyah, I don't know if you're able to type anything into the chat. If you can respond to this, if you can let me know what you get, that would be great. Okay, that's all right. It's fine for you to pass. You don't even have to explain. If you just say pass, that's fine. Not a problem. All right, Jamie, can you tell me how you would get this and what number you would get?
I'm gonna have to pass here.
Okay. Darcy, how about you?
I got 1.7291.
That's correct. Okay, I'm going to share my screen so you can see where that comes from. So we are in the T distribution. We have 19 degrees of freedom because we had 20 in the sample. Degrees of freedom is n minus 1. And then probability in the second row there, we have 0.90. And then we take the positive value of 1.7291. And that's correct. Okay, that's good.
Can you explain the degrees of freedom more? I guess I
Sure.
missed something. I don't understand the whole 20 to 19 or that 15 to 14.
Okay. There's a couple of things, Mary. Number one, it's pretty much impossible for me to explain why we do it. Okay.
Okay.
Number two, if you know the sample size, you just subtract 1 from it, and that's degrees of freedom. So if the sample size is 20, degrees of freedom is 19.
Okay, so we always just subtract 1. Okay.
Currently, yes.
Okay.
We just subtract 1, and that's degrees of freedom. The other part to that is if the software was nicer to us, it would not talk about degrees of freedom. It would just ask us what the sample size was, and it would compute it itself. I mean, why should we have to subtract 1? Why can't the software just do it for us? Because that's what it does when we do the confidence interval. But for whatever reason, mathematics people out there say, oh, wow, degrees of freedom, you really need to know that. And the fact is you don't. But they want you to, so here it is.
Okay, thank you.
All right. Sure. All right, so that's how we find critical values. And again, the previous process that we went through is how to find confidence intervals. And this process is how we find critical values. All right, so what I'm going to do here now, right, we're just going to go through a couple more examples of this, but we don't have to go for another hour because this is all there is. When we look at the homework and we say, okay, what's going on in the homework here? After we go through all the proportion stuffs, right? We have T critical values. We have degrees of freedom. We have confidence intervals. And again, the idea of the point estimate, I should refer to that again. That I'm going back up here in the agenda. When we say we're using the sample mean, we can also say that this is, or the sample mean is a point estimate. But that's not good enough. We know that when I do a sample that it will change. If I just picked a different group of people, it would change. And so I don't want to say that the sample number is the same as the population number, but I will say with an amount of confidence that the sample number gives me a confidence interval and the population number is most likely in that interval. And so when I say point estimate, it's either p hat for proportion or x bar for the mean. And those are the things we're going to do. All right, so we're going to do some more examples here. Oh, I did want to put another thing in here, which does come up in our understanding of this. Okay. And that is number 3. I don't know if I can put a number 3 in here. Should be able to, right? Numbered list, and then I want to change my numbering. Got 3. Yeah. What are the conditions for using this process? Remember that when we did the situation with the proportions, that we said you might need like 500 to 1,000 people in your survey in order to make sure that you have the amount of accuracy that you want. What about this t-distribution stuff? Well, as it turns out, when we're thinking about doing the t-distribution, it requires a bell-shaped population data set. If we really want to make sure that this works, we would have to have bell-shaped population. And unfortunately, that's not always true. So when we said, what about the height of these 5th graders? We were assuming that the height of 5th graders is approximately bell-shaped in order for us to do that. But then the other thing is, we can have relatively small samples to get good results. You know, when we were doing our survey, we had to have hundreds of people in order to get a result that made any sense, that wasn't worth anything. But here, we only needed 15 students to get a pretty decent confidence interval. And so this kind of a situation, we don't have to have the huge numbers like we do if we're surveying people's opinions. We can go with something that's smaller, as long as it's bell-shaped, okay? And so then, does it work? Yes, it works really well if the data is bell-shaped. But if the data is not bell-shaped originally, then we don't know if it's going to work or not. All right, so let's do another example. So let's say that we did this thing with 20 veterans. Okay. Consider a survey of let's just say diastolic blood pressure for veterans. Sample size of 20. A mean of 84 and a sample standard deviation of 8. So we'll start with like an A here. Find the 95% confidence interval for this. Then we're going to change to a sample size of 100. And then we want to change to 99%. And then we want to change the standard deviation to 4. All right, so we're going to find a bunch of confidence intervals here. And we're going to see what happens when we make some changes with this. All right. So let's see if you can use SALT to find these confidence intervals. And I'll set my timer for 3 minutes. See if you can make that happen. And we'll just go to the 10th place for the answers here. All right. Melinda, I think I'll start with you. Can you tell me what happens for the original situation? What is our confidence interval for the mean? In the original situation. Okay, 80.3 to 87.8. All right. Now, I've got 80.3 to 87.7. Right, so mine's a little bit different there, Melinda. I have 87.74. And so that would round off to 87.7. All right, Jacob, can you verify this as what you got as well? Suppose you'll need to type that into chat as well, huh? Okay. Okay. So Jacob, if you have 80.255, then we would round that up to be 80.3. Because anytime we have a 5, then it goes up. All right, so that's the confidence interval that we have for that. All right. So then we're going to change this now. And the question that we're going to ask is, if I have a sample size of 100, how is that going to change my results? So I just put in, I leave everything else the same. I change my sample size to 100. And now I want to know what I get from that. All right. So Jamie, can you tell me what you get if you change the sample size to 100?
I had 82.4 and 85.6.
That's correct. So then, can you tell me what happened then? What's the practical impact of that if we change to a sample size of 100?
Our interval in the middle went down because we're getting more samples, I guess. So
Right. So a larger sample size
because it's more
means
accurate.
it's a more accurate result. That's correct.
Sure.
Okay. Now, I'm going to change my sample size back to 20. And I'm going to change my amount of confidence to be 99%. So now I am more confident about my results. And I want to know what happens when I do that. Darcy, can you tell me what happens if you have the original problem, but then we change it to a 99%?
I got 81.9 and 86.1.
Okay, I think you might have left the sample size at 100.
Okay, which one are we on? Are we on letter C?
We're on letter C, and so we want a sample size of 20, a mean of 84, a standard deviation of 8, and then change to a 99%.
I'll just pass.
Okay, not a problem. Mary, what do you got?
Okay, I gotta go back to the screen. So the lower limit is 82 or 83 to 85.1.
That's not what I have. Okay, so once again, we have a
84,
sample size
8, and 20.
84, 8, 20.
Yeah.
and then a 99%.
Oh, wait, there, okay, sorry, so 78.9 to 81 or 89.1.
That's correct. Okay. So now, Mary, I understand this is confusing, but I want to compare that interval to my original one, which was 80.3 to 87.7. What happened?
See, so there's only a 7 difference. This has, the interval is larger.
Yes, that's correct. So if I have more confidence, if I want to have more confidence, then I'm going to have a less accurate
Less.
interval. Now, it's not a huge difference, but it is some difference, right? So it's making a difference when we say, I want more confidence in this, then it means that my interval is bigger and I'm not so sure anymore about where that number is. I'm sure about the process, but I'm less sure about the numbers. Okay, and then my last option here, where I have a smaller standard deviation. So once again, we're going back to sample mean of 84, but we're going to change the standard deviation to 4 now. We still have a sample size of 20 and a confidence interval of 95%. So I want to see what that number is. So Melinda, do you have that? Okay, 82.1 to 85.9, that's correct. So Melinda, what effect does it have when we have a smaller standard deviation? What does that do to our interval? It makes it smaller. It just makes sense, right? So then that's more accurate. So when we ask the question, how am I going to actually get an idea of the accuracy of my numbers? How can I make this work? Some of that's outside of our control. When we say the standard deviation just is what it is, right? If I go out and measure a bunch of numbers and I get a certain standard deviation, well, I have to go with what that is because that standard deviation is telling me how much variation there is in my data set. And so I go out there, I say, well, what's going on? If my data set is crazy, then I'm just not going to know what my answer is going to be. But if I can measure my standard deviation and I know what it is, then that'll give me an idea of how accurate my numbers are going to be. And most of the time, our numbers are not crazy. Most of the time, our numbers are kind of clustered around the middle, right? So then we can control our confidence, but if I want to say I want to be really sure about this result, then we'll have less accuracy and sample size, as we've seen in the past. If I have a bigger sample size, I'm going to know more about what my situation is. When I was doing my master's degree, I had a sample of 15 epilepsy patients with their heart rate monitors. And so it's like, wow, okay, I've got heart rate monitors on 15 epilepsy patients. That's all I had. I didn't have 300. I only had 15. That's all I had to work with. So I did. Now, of course, nowadays, we have so much data on everybody that we would just have tons of information about people's heart rates, about their calories, about everything else, you know, all these smartwatches and everything. There's tons of data about so many people. But anyway, just so that you know how some of this stuff works. All right, that's all that we need to talk about today. So we're going to call ourselves done. Unless you have some specific question, I'd be happy to answer.
I have a question.
Okay, Darcy.
So in your lesson videos, you use StatCrunch. Is that something that we need to use, or are you just demonstrating on your video?
The second thing is correct. I was just demonstrating on my video how StatCrunch does the problems, but you don't have to do that.
Okay, thanks.
Sure. All right. Any other question about anything? All right, very good. Have a good evening, everybody. Have a great weekend. A nice wintry weekend. I don't know. Nice late fall weekend.
Have a good night, everybody.
Okay.
Bye.
All right, Jacob, you too.